I'm not going to cover a lot of info about the like navigating in Blender and sort of like general Blender stuff. There are lots of really good tutorials out there. This new 2.8 version of Blender is really a lot more intuitive than it used to be. So, for instance, left click is actually to select things now, and some other stuff that, like, at least for me, makes it more intuitive. Hopefully, it'll be the same for you. There is a section here in the manual, I believe, that has some links. You can see down here in the lower right. So there's kind of links to some of the manuals for some of the other specific technologies that Armory relies on, including Blender. So there's a link to some good YouTube videos like Blender Essentials that cover the new interface and give you a nice gentle introduction to that. So I would recommend, if you're not feeling comfortable with just basic navigation in Blender, might be a good place to start would be to watch some of these and then potentially revisit this. We're not going to be using anything fancy, so I will mention a couple of the basics. Right now we just have a cube. What we want to do is just, we want to test that we've installed everything properly. So we're going to first, before we can actually run something using Armory through Blender, we need to save this Blender project file. So we can do that by clicking on File and then Save As. And you can choose your location here. I'm just going to make a new folder. I'm going to call it Practice. And then you can click in here. And we just need to give a name here to our Blender project. So I'm going to call mine Practice Blend. And you can click where it says Save as Blender file here. So now we should have it saved. So we can talk a little bit about Blender here quickly. Since we have a bit of time while we just sort out some technical difficulties. So you can zoom in and out using the mouse wheel. Generally, it'll be easier, I would say, if you have a mouse rather than a touchpad. But do it however you're comfortable. If you click the middle mouse, you can kind of freely rotate around, which is quite handy. There's lots and lots of buttons. The interface, will be intuitive if you go through some of the Blender essentials. We're going to be using a lot of these kind of tabs over here on the right side that let you kind of view different pertinent information about whatever you currently have in your scene here in the center. Up here in the top right is what I think of as a scene graph. I'm not really a Blender expert myself, so Blender might have some specific terms for these things that I'm not aware of, but this is just a list of your hierarchy of objects that are in your scene, essentially. So things like your camera, which is this thing, your light, and the cube here. That's all we've got for the moment, but that will soon change. There's a lot of different hotkeys within Blender. I know almost none of them, but I'm gradually learning as I go along. They can speed up your workflow quite a bit if you kind of start to learn the hotkeys for common actions. So to begin with, you might be using a lot of the UI, but generally, if you hover over some of these UI buttons, then they'll show you the shortcut on the keyboard for accessing things. So we're going to use a couple of those as we go along. Up here at the top, there's ways to add new things to your scene. And you can get a list of different things that are available, different types of mesh, geometry, and lights and other fun stuff. So the first thing that we want to do now that we've saved is actually run and just test that we can run our game in interactive mode through Armory. So to do that, over here on the right side, you'll see this little thing. Looks like a TV type dealie. This is the render panel. And if you scroll down, if we've installed Armory, you should see you'll have some Armory-specific options for the add-on, one of which is play. And again, if you hover over it, you'll see the shortcut for this is F5. So when we want to run things, we can either press F5 or we can click this play button, whatever we're more comfortable with. Let's go ahead and give that a shot and see. There might be a slight delay when you first run it, but hopefully we'll get something like this. I'm going to adjust the size a little of what I've got here. If it pops up and it's huge like that, if you're on Windows, by the way, you can use Alt F4 to close the window. Just make sure you have the actual focus on the game that's running and not Blender. Then you'll close Blender. So you might be in a similar situation to me where your window just popping up is way too large. That's something that we can adjust. So there's this tab over here for the output context. Looks like a little printer icon. And you can change the resolution, output resolution. So I'm just going to scale mine down to 50% for now and not mess with anything else. You can save Control S, as you're probably aware, is a shortcut for saving. And I'm going to go back and run it again. Okay, that's a bit more like it. That's a good size. So there we have it. This is our first scene running within Armory. It's completely non-interactive, which is not ideal for a video game. So let's close out of here. There's one actual very quick way to get just some minimal interactivity here, which is in the options over here on the right, where it says camera. It is defaulting to scene. If you click the drop down and choose viewport instead, and then give it another run, you'll have this other mode. You'll see you're like a bit further back now, and you can actually have some control. So if you left click and drag, then you can orient the camera view, and WASD gives you some movement. So you have some pretty standard game style free floating camera movement now to navigate around the scene. So the viewport mode just kind of gives you that by default. So we'll basically be using that a lot early on, just since it's convenient. So we can close out here. So just go ahead and keep a viewport selected as that option. So let's go ahead and add some ground here for our first little environment. So there's different ways to do this. As mentioned, you can click the add button up here, and you can find things like planes and stuff like that. There's also a hotkey for it, and this is one that's super useful, so I'm going to mention it. If you press F3, I believe in old Blender this used to be spacebar, so depending on your settings, if you have the old settings, it might be spacebar. This brings up a search, and this is just a quick way to access a lot of the different stuff that you can get to through the UI, but just through a faster method. So if you search for add plane, we're going to add a ground plane to our 3D environment here, so you can go ahead and click that. You won't be able to see it very much, but you have a plane that's selected. It's just kind of tiny right now. So the first thing that we want to do with that selected is scale it up a bit. And so again, there's ways to do it like over here, but I'm going to use the hotkey, which is S. So if you press S, you'll go into scale mode, and you can just move the mouse a bit to give ourselves a bit more space here. And go ahead and left click once you've got a decent size. It doesn't need to be huge. This is going to be a pretty simple starter project. So I've got our ground plane. One thing to notice is it's showing up as well in this kind of scene graph, scene collection thing up here that I mentioned earlier. So if you ever can't find anything for whatever reason here in your actual scene view, then you can find it up here in the graph. So one problem that we have here is our little cube is intersecting our plane. We probably want to move that up a bit. So we can go ahead and click on that, left click to select it. And when you have it selected, you'll see it has this little outline. And we can actually access some properties of it by using this little square tab over here. This is the object context. So, if you've ever used really any 3D game editor like Unity or similar, this is all probably going to be quite familiar to you. So you can change the positions and scale and things like that. So in this case, Z will be our kind of up and down vertical axis at the moment. So we could change this. If we want to change this to 1 meter up, then it should be more or less flush with the ground plane. This is the unit cube. And before we try to run this again, let's just make it a little more visually interesting to look at by adding like a little bit of color to our objects. So the way that we can do some shading and similar effects is if we click on this, you'll see there's a bunch of tabs over here that will probably be up by default with Blender 2.8. And you can kind of scroll through them. So one of them will be this shading tab. So go ahead and click on that. That's going to bring up this shader view within Blender. And you have this kind of node-based shader scripting that you can do. We're going to keep it real simple for now. So down here, and by the way, obviously this is quite zoomed out right now. Similar controls to the other view. You can use the mouse wheel to zoom in and zoom out. And if you click the middle mouse button and move, you can drag around. So we're just going to change the base color here for our cube. Make sure that you have your cube selected, by the way. Let's go ahead and click on this. Use whatever color you want. I'm going to go with blue. And then I'm going to select my plane. You can click on, if you want to go back to layout mode, you can click on layout. I don't think it's strictly necessary. I've been doing it out of paranoia because I did have some crashes with Armory here and there. Again, just to reiterate, so I think I mentioned this at the outset, but the developers of Armory is very much in active development. I would encourage you to support it. The creators, have explicitly said at the moment that it's not production ready. Which is why we're kind of just dabbling into it at the moment. I think it's a really great thing to experiment with for game jams. I wouldn't recommend trying to build a commercial game on top of it at the moment. So anyway, it's doing a couple of circuitous things just to avoid areas where I've happened to have had some crashes here and there. Mostly it's been really stable on most of the machines I've used it on, which is impressive. So anyway, back to what we're doing. So select your plane and go to the, so go to the layout mode, select your plane. And we're just going to add a material. So our kind of unit cube that we started with already had a material on it by default that we could edit. Before we can, change the color of our plane, we need to just add a basic material to it. So you can do that down here from this little tab kind of towards the bottom in the lower right, the material context. We're just going to add a new one. So there's this little new button. Go ahead and click that. So now we have a material, and for something as basic as this, we don't really need any kind of complex, shader logic. So we can really just edit the properties directly from here. So let's go ahead and do it from here this time, so you can change the base color. And again, whatever you desire. This kind of orange color. And so let's go ahead and run our game again. This time, instead of going to the render tab, I'm just going to press F5. And so here we have, we're getting to a little something, at least. So we've got a scene, with a light and a movable camera and some basic geometry. Still no real interactivity and no collision or physics. So let's move along. Make sure that you have saved your progress so far. So I'm kind of going through what is the playground example if you go through the docs. There's a lot of like little things that they show that I'm honestly going to skip over, just because I think, you know, they're things that are easy enough to explore on your own. And I want to get to just kind of what are some of the key features. But there's lots of little fun things that you can do. They add some little like modifiers to the cubes and things like this to make it beveled, and they add some sort of like texturing stuff and like a skybox. I may not cover that stuff this time. Probably leave that as an exercise to you, the viewer. But do definitely check that out after we're done with some of the basics here. So the next thing that I'm going to do is I'm going to add some physics in. So to add some physics onto our box here, if you've ever used Unity or a similar tool before, it's a pretty similar workflow here in Armory to what you might be used to. So we need to add a rigid body component. Armory happens to use the word traits, but as best I can tell, what Armory refers to as traits is pretty much just what you would think of as a component in another tool. So to do that, we're going to go to this physics context tab over here. Make sure that you have your box selected. And we want to choose the rigid body option. And then we'll get a bunch of details where we can set things like the mass and the type of collision shape and so on. We want to make sure by default it should be set to active. For the collision shape, it defaults to this convex hull. For a simple shape like this box, we can use a simpler type of collision volume. So go ahead and click that drop down and just choose box. So you could save it. You could go ahead and try to run it. I'm going to press F5. And lo and behold, we have a box falling through our ground plane because we did not add any kind of physics to our ground plane. So go ahead and close, and then click our ground plane to select it. And same thing, we're going to make sure that you go to the physics context. It'll probably still be open. Choose rigid body. In this case, for the ground, instead of it being active, we're going to give it the passive type of collision. Again, you can just hover over these things to get like a little bit more detail about what they actually mean. Similarly, we don't really need the convex hull. I think that's sort of overboard for a plane. In this case, we can just use the box. Again, it even says here, as you'll notice in the little tooltip, that it includes planes. Cool. And we can go ahead and save that and give it a run. And lovely. Our box is on solid ground. So now that we are on terra firma, again, go ahead and make sure that you have saved what you've done so far. Let's see. So, I kind of debated about what to cover next because there's some really cool things about the fact that this is all in Blender. Just because Blender is such a powerful tool for 3D modeling and other types of activities. So the example actually shows some stuff about, for instance, like animating an object on using a timeline animation. I'm not going to dwell on that too much, but we are going to do a kind of logic-based animation. But you can actually, you could just, do a sort of like cutscene style pre-baked animation if you want, and sort of intersperse that within your scene, which is I think is pretty neat. And because it's Blender, like it all is just kind of integrated without you needing to do a lot of extra work to integrate it. So that's one of the things that I think is really promising about this idea of, a game making tool that integrates with Blender. So we're just going to add another shape in as our next thing. So remember that F3 is the hotkey for adding. And instead of adding a plane, I'm going to add a cylinder. this time. And we can click that. Again, so we've got our cylinder selected here that we've just added. I'm going to mess with some of its object properties by bringing up the object context over here. So I'm going to, I think, rotate it because I want it to be, I want to make like kind of like a little rolling pin type cylinder. So I'm going to change its rotation to be 90 degrees. Oops, I'm rotating around the wrong axis here. So go ahead and change the x-axis rotation to 90 degrees. You know, I mean, you can do it either way. But, and what else? As long as we have it selected, I'm going to go ahead and, I think, scale it a little bit. So I want to make it like a bit longer. So I'll show you like another little hotkey trick. This is really more of a Blender thing than anything. But so remember from when we scaled up our plane, if you press S, it'll switch you over to scale mode. One thing you can do when you're in mode like this is you can press X, Y, or Z to just sort of lock to a particular axis. So if you only want to scale up in one direction, then you can press S to go into scale mode, and then press, in my case, I pressed X so that I'm doing it along the x-axis here. And then click when you want to commit. By the way, Control Z is undo, much like you might expect. If you make a mistake and want to go back. And with it still selected, I want to kind of move its location just so it's not intersecting with anything. So I'm just going to move it a little bit over to the side in the X, so 3 meters over. Let's just take a look and see what this lovely world looks like now.
I have a question.
Yeah.
So, is there a reason why you have not switched to the Eevee renderer? So, when I say Eevee renderer, I don't mean in the play mode, but I'm talking about in the editor mode. On the upper right-hand corner, by upper right-hand corner, I mean in the editor window, right above the 6-axis coordinate. Yeah, it's possible to switch viewport shading, which will more accurately reflect what the final renderer will look like.
Cool. Yeah, the reason why is that, like I said, I barely use Blender. So, which of these two would you recommend, Taro?
I'll get back to you on that.
Yes. So, very good suggestion from Taro here, which is you change the shading here that you can get a better preview of what it's actually going to look like. And sort of parity between what you're looking at within Blender and what it actually looks like in the game is, again, like another one of the potential advantages here. So that's a really good tip to kind of switch this into something that's going to render things here in the editor more like it's actually going to render it in-game. Since I'm not super concerned with visuals, I didn't even realize that I could do that. So that's great. Okay, so let's go back to our friend the cylinder here. By the way, sorry, before we do that, I know I'm jumping around here, but you can also mess with the lighting, and now that we've kind of changed the render mode, this might be a good time to highlight that. So you can click, I happen to do it just here in the scene graph, and then down here there's an object data tab where you can change things like the color of the light, and just the intensity of it, things like that. I'm not going to mess with it too much, but feel free if you're so inclined. But I'm going to reselect my cylinder, and we're going to take a look at logic nodes. So There's different ways to get to, so essentially Armory supplies some visual scripting type behavior similar to what you might have seen in a tool like Unreal. So you can script a lot of your game logic if you're so inclined using visual node-based scripting. And we're just going to do a very simple behavior, and then we'll look at other forms of scripting an object after that. So we're going to go back to our shading tab up here at the top. So in the shading view. And again, with the cylinder selected, you can change the type of the editor, so it will most likely be still doing the visual material shading, but what we want to do is choose the logic node editor. And we just want to write a simple script that's going to make this cylinder kind of roll back and forth like a little rolling pin along the ground plane, just in sort of an oscillating fashion, back and forth. So you can add logic nodes by clicking this add, or the shortcut happens to be Shift-A here. And generally speaking, there's a few different types of logic nodes. There are events, which are kind of like triggers to start something off, like a conditional trigger. Actions, which actually do stuff. Logic, variables, and values. So what we're going to do is we're just going to start with an event. So we want to do something that's going to basically update our object. So onUpdate is the typical event for that. So you can go ahead and click that. Oh, I'm sorry, I skipped a step here. You do need to add a new node tree. So just go ahead and click here where it says new. And I'm going to give this a name before I forget. So by default, it's node tree. I'm going to call this our move cylinder logic. And now, once you've done that, you can do add event and onUpdate. It should work for you. So if you've never done like node-based scripting before, this might take some getting used to. And actually, if you've done coding in a more traditional form, it might also take some getting used to for you. But this is essentially like a callback within code that's going to get triggered every time that our logic updates. And then we're going to perform some action in response. So we can add an action. And in this case, what we're going to be doing is just directly setting the location of the cylinder. So we can choose set location. And the way that this kind of works is you just wire these connections together between these nodes. So in this case, we want to wire the output node of our onUpdate to the input node of our set location. So when the onUpdate event fires, then it's going to perform this action of setting the location of the cylinder. Now, the actual location that we want to set it to is a bit trickier potentially. So we want it, I kind of want it going back and forth. This is also a cool thing from the playground example. I liked how they set that up. So I want to do something similar. So I'm going to need to actually give it a location. This is the other sort of parameter input into this. And so that's going to be a three-dimensional vector. And so you can find that under add, and then there are different types of variables. So these are sort of standard variable types that you'll often see in 3D games, one of which is vector. So we're going to add that. And so we're going to use this as what we pass in the set location, but we need to add some kind of other logic node to basically fill out what the positions are for this vector. And basically what I want to do is I just want to move it along one axis. I don't really want to, the movement to be too chaotic. So I'm just going to keep the y and the z like essentially as they are. And then I'm just going to have the x like kind of do like a sine wave type motion where it goes back and forth. So let's go ahead and do the x first, since that's probably the more complicated part. So there's a section here for values. And if you scroll down a bit, one of the sections is for mathematical values. So you'll be using this a lot for values that you calculate based on some game logic. So in this case, what we want to do is we want to use a sine wave value. So we've got our little math node here. If you click this drop down where it says add, you'll find, so here's a bunch of mathematical functions, right? Mathematical operations that you can perform using this math node. So the one that I want to use is just a sine, I want to get a sine value. So that's great. I could actually like use that as input into my x coordinate, and it would be probably causing some kind of movement. But I'm going to add one other little nicety, which is I'm going to take that value, which would be, we would expect it to be a number between 0 and 1, unless we, somehow change it. So I want to kind of scale it so that it's a little less subtle of movement. So I'm going to go ahead and just preemptively do that. If you click add, once again under value math, as I mentioned, that's going to be one that if you do a lot of this visual scripting, I suspect you'll be using quite a bit. Let's get a little space here. So we just want to basically scale up this sine value. And the way that I'm going to do that is just by multiplying it by a value here. So in this case, let's say 4 for now. We'll see what that ends up looking like. And we want to wire this sine value into this multiplier. So now the two, I'm forgetting my mathematical terminology here, operands. Anyway, the two values that you're supplying to the multiply operation are going to be the sine value and then 4. So that's going to multiply, our sine value and scale it up. And then we're going to take that output and we're going to use that as the x value for our positional vector. Now, the sine value actually also needs something to basically change it over time. And this might not be immediately intuitive, but we need to give it like basically an increasing value. So we're going to give it a time value, just so that the sine function has its own input that will then cause it to be changing. So we can find that under, again, if you click add, I believe it's under value as well. If you scroll down in this big old list, then you'll find time. So value has like all these different values that you can look up about the current state of the game, including the time that's passed. And we just are going to use like actual time as our input value here. So as time increases, that value is going to get supplied to the sine function, and then the sine function is going to give us this oscillating value between 0 and 1, and then we're going to scale that up, and then that's going to be our x. So hopefully that will give us a nice back and forth type motion. Now, we still need to fill out the y and the z, and we don't want them to be 0. We want them to just be basically like whatever they are already. We're not going to modify them. So we need to get the current y and z coordinates of the cylinder, and we want to like basically keep those rather than zeroing them out. So in order to do that, we're going to do add here, and this is I think the one that I've been forgetting. I think it's also under value. When in doubt, a lot of these things are under value. So the thing that we want to do here is we're going to take the positional value, and we just want the y and the z. And so there's a logic node we can use to just kind of split out the individual components of a vector, and that's the separate x, y, z. So again, we've got the x coming in from this other function. We're just going to be supplying the y and the z here. And we need to feed into this separate x, y, z the current location of the cylinder. So, under add, once again, value, get location. And again, because this is going to get, this script is going to be attached onto an object, we can assume that it's getting the location of whatever the object is that it's attached to. Same with set location. So we didn't need to actually like explicitly tell it cylinder. That's something that we're going to hook up separately. So we just need to connect these like so. And there you have it. So there's our little node-based logic. So that's quite far that we've gone without actually testing it, but now we should be at a point where we can do that. So go ahead and save. And the last thing that we need to do is we actually need to add this logic to the cylinder. So as noted, we've just kind of set this up here, but we haven't actually like attached it. So I'm going to go back to my layout view to do that. Again, I don't think you necessarily need to, but what you can do is under the object context, if you scroll down, then under Armory traits, you can add a new one, and you want to choose nodes. So these are different types of scripts that you can add. In this case, we've just added our visual tree node, and we need to click here where we have this box, and it's going to give us a list of the ones that we have set up. So move cylinder should be in there. So that's how we associate that logic that we've just set up with our cylinder. So we can go ahead and run this using F5. And hopefully you'll be seeing something that is not too far off from this. And so I would encourage you to just, mess around with that, as an experiment on your own, like change around some of those values, scale up the amount that you're multiplying it, try to see, what else you can do to make this a little more interesting. So one thing that springs to mind that we can do to make this a little more interesting is actually make it collide with things. So we added collision to our box and our plane, but we haven't done so for our cylinder. So let's go ahead and do that. I'm going to do one thing first, which is something I probably should have done a little bit sooner, but I'm going to move this box up a little bit just to prevent any initial intersections that might occur. I know we kind of moved things out of the way before, but now that we're programmatically setting the location of our cylinder, we could be causing some intersections accidentally in the initial state. So we'll click our box here and go to the object properties. Again, there are different ways to do this. You can just drag things around within the editor. I just happen to, when I'm doing something simple like that, just set the locations explicitly. So I'm gonna, just move this up a ways, 4 or 5 meters up. This would be a good way as well to just test our physics on the box, which is why I say I probably should have done this a little bit sooner. So we can go ahead and run this and just double check that it actually has gravity on it correctly, like this. Let's go ahead and add physics to the cylinder. So click to select it, and same as we did for our box and our plane, we're going to go to the physics tab over here and give it a rigid body. Now, if you're moving something, directly by setting its location, using logic or using timeline animation or things like this, then you don't kind of want it to be fighting the physics system. You want to kind of minimize that as much as you can. So what I would suggest is just to set this to passive, similar to what we did for the plane. And I was kind of messing around with some of these settings before. I won't say that I've found like the perfect settings for having physical things and sort of logic-based things interacting. I was having good luck with this animated checkbox, but I'm not an expert as to why that was giving me good results. But try it with it on or off, see what you get. I'm going to put it on. And we need to change the collision shape. We don't need to, but I would suggest it. Generally, if it's a geometric primitive, try to pick a collision shape that matches it. In this case, the cylinder. And let's go ahead and save this and run it. Let's see what we get. Cool. Nice. So we've covered how to add physics using rigid body and collision volumes. We've covered how to do some node-based logic. We've covered the absolute simplest type of material changes that we could. The last thing that I wanted to show was just how to do a bit of text-based scripting. I think I mentioned at the beginning, Armory uses HAX as its default programming language, which is a really good programming language. I actually quite like to use it outside of the context of Armory. I recommend trying it out. It's worth learning. It's a language that can cross-compile to multiple other languages, including C++ and JavaScript. So it's a nice language to learn if you're trying to do cross-platform projects. And I'm guessing that's one of the reasons why Armory chose to adopt it as its sort of native language, because one of the stated goals of Armory is portability. So we're going to dive into some HAX scripting. And we're just going to add like a little spawner where we can spawn some more boxes into the world and get some nice physics interactions going. Before you do this step, you will need to install some type of code editor. If you haven't already, if you already have Visual Studio installed, that'll work just fine. And if you're checking out the documentation, then they recommend towards the bottom also that you install the Ka extension pack, just to get some nicer kind of syntax highlighting and other stuff. Or they recommend just using Code Studio, which is an IDE that works nicely with HAX natively without you kind of needing to fiddle with it too much. So those are kind of the two recommended editors, and there's others you can use. You can use whatever code editor you like. But if you want some kind of decent integrated debugging and, just things that'll make your life easier, then those are probably your best bet. So I happen to have pre-installed that, so I'm going to kind of leave that as an exercise for you. So let's go ahead and add in our little box spawner here. First thing that I'm going to do is I'm just going to take this box and move it kind of like underneath the world so it doesn't get in our way. So after going to all the trouble of putting that up in the air, I'm now going to move it again. Just to like -5. So we want to add a spawn point within the world, and then we're going to attach a script to it. So you can add just an empty point into your world, same way that we've added these other shapes. If we press F3 to bring up our search, you can do add empty. And if you click this, it's going to bring up some other options around how you actually visualize the empty point. So you can choose whatever you like for that. I'm just going to do plain axes. It'll show up over here. in your scene graph. So I'm going to change the name of this from empty to box spawn point. While I'm at it, I think I'm going to rename this cube to box, just for fun. And so I want to click on my box spawn point here, and so right now it's at the origin. We want to kind of move it up a ways. So I'm going to click on the object tab and change the Z location to be somewhere a bit higher up in the air here. That'll do. And now we want to attach a script to it. So you can do that also from this object tab if you scroll down. So again, we did this actually before with our node-based script. It's the same way. We're just going to add a hack script instead of a node-based script. So here, under here where it says Armory traits, you can add a new one with this little plus. Again, make sure that you have your box spawn point selected. And you can choose hacks. And so that'll add in a hack script. And you want to, after you do that, you want to click New Script. And then we're going to give it a name. I'm going to call this spawn box. That's the basic behavior that we're going to set up. And click OK. And so it should have changed the name here, that script trait. And now we want to actually edit it. So if you click this Edit Script button, in my case, it's going to pop up my code editor, which is Code Studio in my case. If you haven't installed an editor, then you'll get some kind of prompt asking you to associate one with hacks files. So you can go ahead and make sure that you do that. Yes, yes. Okay. So this is what we'll get by default, which is our empty script here where we just have this package statement at the top, and then hacks as an object-oriented language. So here we have a class declaration for our script. And it is deriving from or extending iron.trait. So iron, you can read up on it more on the Armory website. That's essentially the name of the fundamental sort of like engine libraries that Armory is using. There are some like files that are called Armory and some that are called Iron. There's a lot of things that are just a little, it's definitely like pulling from a bunch of different open source projects. So I would definitely recommend that you look up the API documentation. Again, we're not going to get into anything too complicated right now. But it is, there's quite a few different libraries that you have access to under the hood. So there's a lot of functionality there. You just kind of need to find where it is, as always. So I'm going to go ahead and cheat a little because I'm feeling kind of lazy at the moment. And I'm just going to copy in the script from the example here. For what they call the playground, which is kind of like what we've been going through. So if you're looking through the documentation over here on the side, we've been going through some parts, selected parts of the playground tutorial, skipping over some of the stuff to do with texturing and things like that. But they have a built-in script here that they have for just spawning boxes based on a key press. And I'm going to blatantly rip it off from this example, and we'll pop it into this script. And then we can take a look at what it's actually doing from here, but I'm just too lazy to type it in at the moment. So as you can see, we have still our class declaration here. We're actually now importing some of these modules from the Iron library and also the rigid body from Armory. So the first thing that we have here is our constructor. Bear with my C++ terminology. here. I believe hacks may call it a constructor as well. So this is the function that's going to get called automatically when the script is run. And the thing that you want to set up is basically you want to set up your update function to actually get called as a callback when on-update event triggers. So that's all this line is doing, is saying there's this update function that we've defined here within the class, and that's going to get called. So that's all we're doing. Super, this is a hacks thing where you, and some other languages have this, where you can explicitly call the super class constructor. So that's just going to make sure, that's just sort of a little insurance policy to make sure that the base class gets initialized properly, things like that. So within the update function, we just want to test for whether or not the F key has been pressed. So that's being done using this input. So that's this library here, iron.system.input. Has a get keyboard function, and then you can test when a key has initially been pressed, which is started. So we're testing for the F key. And then that's going to actually spawn a new object within the active scene. And then it's going to also supply this box spawning function that's going to fill out a few of the properties. So that's the 20,000 feet view here. So I'm going to go ahead and save this. And let's hop back over to Blender. Make sure that we've saved. And let's give this a run using F5. And I'm going to go ahead and press F to pay my respects. And I'm going to keep pressing it, because what's the fun of having a 3D physics system? You can't go bonkers with it. So you can use the physics system of your choice. I believe that bullet is what's being used by default, but it's they've kind of set it up to be as easy as possible for you to swap it out. As you can see, there's like a little bit of intersection going on with the cylinder and the square. It's probably just due to the collision volumes, the way that I've set them up. But yeah, some fun with box spawning. So that's all well and good to be able to spawn some stuff into the scene, move around. It's not the most exciting. I kind of want to be able to just like do something with the boxes. So the good news is, if we go back to Blender, there's already a fair number of built-in scripts for common behaviors that Armory comes equipped with. So in this case, I want to put one of those on my box object. So when we're spawning new things in, we're basically like instantiating new box objects here. So if we add some behavior scripts onto that, then the new ones that are spawned will have that behavior. So if you select your box, and over here in the Objects panel under Armory Traits, you can click plus. And so there's all these different options, one of which is Bundle. And if you click OK, then again it's going to pop up just an empty placeholder slot for the script. But if you click here next to where it says class, then here's a list of the built-in stuff that's available at the moment, with more stuff being added over time. So in this case, I'm going to add the physics drag behavior onto our boxes, and go ahead and save and run. So if we click on just empty space here, we still get our viewport camera movement. If we spawn some boxes, if we click on one now, we can actually get some interactivity here, where we can chuck some boxes around. Not too shabby for a few clicks. Set that up. So we've covered different forms of scripting. Now visual and more traditional scripting. I had said that was the last thing. I just really quickly realized that I wanted to show how to do some UI because it's super simple. So let's just do that super quick before we wrap up. So there's this little Armory 2D like UI tool that pops up, and you might have noticed that it was one of the options when we were adding new scripts was a UI. But we want to not add that onto an object. We want to add it just onto the scene itself. Thankfully, over here on the right side, there's a scene tab. This one here. And you can add traits to the scene itself, just like you can for objects. So in this case, we're going to add a new trait, as they call it, and we're going to select UI, click OK, and much like we had to do when we were adding a hack script, we had to say new script. In this case, we're going to do new canvas. And you can give it a name, whatever you want. I'm going to call mine HUD or heads up display. And you can click OK. And then if you want to edit it, you just click this Edit Canvas button. And it's going to pop up your Armory 2D UI editor here. And so let's just keep it simple. We're not going to do anything too fancy, but let's just add some instructional text. So if you click the text button over here, then it will add one into your UI layout view. And so we could expand this a bit. Just give us a little more space. And over here on the right side are properties. So you can change the text to whatever you wish. A little bit hard at the moment. Can't really see it. You can't either, probably. So yeah, over here on the right. So we could add some instructions, like press F to spawn a box. Just going to get rid of my enthusiastic exclamation point. And then once you've edited your UI to your liking, you can click Save and close out of here. And go ahead and run your game one more time using F5. And there we have it. Cool. So, that about does it for the intro to Armory at the moment. You know, it's still being actively developed towards you know, a nice stable release that will hopefully be something that a lot of us can use to build larger games off of in the future. But for now, I definitely recommend that you keep playing around with it and maybe try to use it for some smaller projects and game jams and things. It really is. It's just nice to have all these things integrated and you know, in a free open source package. Like, it's pretty incredible, you know, the amount of different projects that have come together just to get to the point of us having a tool like this. So I'm going to be keeping an eye on it. So as far as next steps go, let's close out of here. Let's go back here. So as noted, the playground example has some other stuff that is certainly well worth checking out that I just kind of elided over this time. So you can add sort of visual modifiers to things. Materials is a big one that I admittedly skipped over. I didn't mess around much with like texturing or anything like that, but they have, you know, pretty good section covering that stuff. And it's a Snapchat, a skybox as well, which is why I figured like I wouldn't spend too long covering it because it's really like a couple clicks to add a skybox, so you can do it on your own and feel accomplished. Yeah, they cover kind of how to import assets and so on. Yeah. They mentioned as well, so you can set up kind of different render settings for different targets. This really is built on top of tools that are designed for portability across different platforms. So, it is at least moving towards a good kind of write once, run anywhere thing, but you may still need to make some tweaks to your render settings, things like that. So you could set up those things. And there's an exporter as well. So let's just take a quick look at where that is. I'm not going to mess with it too much, but if you go to the render context and scroll down, same place that we were changing our camera view, there's the Armory exporter and Armory render path. So you can build your project for different targets here. And natively you can build for open web standards, HTML5, and I haven't really tried out mobile, admittedly, but I believe you can do mobile builds. But I've had really good luck with desktop and web builds. I've tried both of those, and performance-wise is like pretty solid, admittedly for a pretty simple scene, but it seemed promising. So that's great. Do note that if you export an HTML5 build and try to run it locally, it will not work. You do need to actually be running it via a server, which when you run it through Armory, through Blender, it will automatically do for you. But if you run the exported version, it will not be doing that. So you may need to upload it to like itch.io or just run a simple local HTTP server in order to see anything. Otherwise, you might just get a blank, what looks like it's not doing anything, which happened to me. And yeah, last but not least, there's a more advanced tutorial, which is outside the scope of this lesson, but there's kind of a tanks game, and there's some examples you can download and also some game templates that are really worth checking out. So I recommend messing around with these. We can take a quick look. So let's see here. Let me see what I have in my recents. So you can also download a fancier version of this playground thing here. So this is a version where they've just added some other stuff, including this little humanoid mesh. So we can give that a run, see what that looks like. Some things will be very familiar here. But they've also got, so this is a sort of timeline animation, this rotating box. And here you have something that's obviously an animated thing that's just built in. So that's the playground. And you can also check out the tanks example. So this is just a little local multiplayer, two-player tank game where you can move around and fire some little Nerf doodads at each other. And I think the goal is just to knock the opponent off the stage. And you can redesign this this stage since it's kind of a close quarters duel as it stands right now. So yeah, it's like a little sumo tank game, which is neat. And that would be, I think a good next step that I would recommend in terms of getting a little more into the scripting, which, admittedly I really glossed over in the initial lesson. I didn't want to overwhelm people too much with the scripting, but this is a good next step that's still not too overwhelming, but they have a few different scripts set up on the tank objects. And yeah, just, again, still like pretty simple scripts, but just starting to get into a little more detail on what you can do. So yeah, that's Armory. I'm trying to think if there's anything else at the moment. So I believe there's a Patreon for Armory if you'd like to support the developers, which I definitely would encourage you to do. So if you go to armory3d.org, then I believe you can access it from there. I'm sure it's hopefully somewhere prominent. Donate. and then you'll end up in a weird place. But yeah, they're definitely updating lots of stuff very rapidly, so you may need to just Google that in order to find it. Cool. That's Armory. Thanks, everybody. Any questions?
Remember to support us on Patreon at patreon.com/techvalleygamespace.
Yeah, support all the Patreons. Oh, support Blender as well, of course.
Mm-hmm.
Yeah, I mean, a lot of this is piggybacking off Blender, which is amazing.
Yes.
If you haven't tried out Blender 2.8, if you were previously feeling daunted about Blender, obviously there's still a lot of stuff in it, but man, the interface is improved by leaps and bounds, in my opinion.
The only other thing that comes to my mind is that we obviously have the regular Sunday streaming, so feel free to join us on that. Yeah.
Cool. All right, well, with that, I think we will bid you all farewell. Thanks for joining us for another TVGS lesson night, and we will see you soon.